I would say a software engineer, in the traditional terms, build the features for the customers. And in contrast, a platform engineer build the product that the software engineers use. The distinction matters because if you treat platform engineering as just another flavor of software engineering, you underinvest in the foundational layer. You want all the Teslas look same, behave same. You don't want one Tesla would be running in a different operating system. It means customer will get a inconsistent things. The most common mistake is treating platform engineering as a tuning project instead of a product and the organizational capability. Most valuable people will be those who can design the systems that let AI and human ship reliably at scale. On the platform or the cost of not having one will show up in your P&L, your risk report, and your customer matrices as well.
Welcome to the Paalam Labs podcast, where we bridge business strategy and emerging technology one conversation at a time. I'm Tipu Swaran, founder of Paalam Labs, and your host for today's conversation. Over the past 20 years, I've had the privilege of working with some of the world's leading Fortune 500 companies, driving digital strategies and large-scale transformations that sit at the intersection of business and technology. I'm passionate about one thing above everything else: turning complex ideas into actionable insights. I do that through my thought leadership on Forbes and through conversations like this one, by sitting down with leaders who are operating at the frontier of enterprise technology. Today, we're talking about platform engineering, and more specifically, what it means for the boardroom. Imagine asking a Formula One driver to also build a car before every race. Design the engine, tune the aerodynamics, wire the electronics, and then, once all of that is done, get in and win the race. That's absurd, right? The skills required to build a championship car and the skills required to drive one at 200 miles per hour are completely different. Separating those two roles isn't inefficiency. It's what makes peak performance possible. For most of the history of enterprise software, that's exactly what we were asking software engineers to do. They had to both build the software for customer features and the platform to build the software. The driver was also building the car. The agile era changed how teams work. Ship faster, iterate constantly, get features to customers before the competition does. It was the right philosophy, but in the race to move fast, someone still had to build a car. And for a very long time, that someone was the same person driving it. As enterprises scaled, hundreds of engineering teams, dozens of cloud environments, thousands of services talking to each other, the complexity crossed a threshold where one person simply couldn't do both jobs well. Something had to give. Google saw it first, then Netflix, then Airbnb. They started building dedicated platforms. So the driver could focus entirely on winning the race, while a specialized team focused on building and perfecting the car. The software engineer focused on the customer, the platform engineer focused on the enterprise machine that made delivery possible. Two distinct disciplines, two distinct purposes. One powerful combination. That separation and the discipline built around it is platform engineering. And if you're wondering where continuous integration and continuous deployment or CI/CD fits in, think of it as the pit stop, the precise automated process that gets the car back on track fast. It's not the driver and it's not the car. It's the repeatable, optimized handoff that keeps the race moving. Platform engineering is everything that makes a world-class pit stop possible. The tools, the systems, the governance. The team behind the team. Here's what makes this moment different from every moment before it. AI has entered the race. And it isn't just making the pit stop faster, it's compressing the entire upstream of software delivery. Requirements, design, architecture in ways that would have been unimaginable 2 years ago. The platform that was built to govern one area of software delivery now has to evolve to govern an entirely new one. Most enterprises aren't ready for that, and most boardrooms don't even know it's happening. My guest today has spent living at this intersection. Dr. Gaurav Shekhar is a technology executive leader at a major financial services institution, an IEEE Senior Member, a SPAC's chair, a research scholar, and a 5 times published author. His latest book, Ultimate CI/CD for Platform Engineering, is a practitioner's blueprint for building the kind of platform engineering capability that doesn't just serve engineering teams but delivers enterprise outcomes. But what makes Gaurav a rare voice in this space is that he doesn't just write for engineers. He writes for the leaders who need to understand why this matters beyond the technology organization. His work is an attempt to give the C-suite a language for platform engineering. And that's exactly the conversation we are here to have today. At Paalam Labs, we believe in the power of bridges, connections that close the gap between where things are and where they need to be. Gaurav is building one of the most important bridges in enterprise technology today, between the engineering teams who build the platform and the business leaders who depend on it, whether they know it or not. That gap between what platform engineering is and what it can do for your enterprise is exactly what we are here to explore. Let's bridge that gap. Gaurav, thanks a lot. Totally appreciate you joining the podcast. We're going to tackle a specific kind of more technical topic, but we have had conversations on how this particular topic associated with CI/CD and platform engineering impacts organizations at large. It's a key imperative at the C-suite level, which I think the C-suite is not necessarily looking at as much as they should. So before we dive into the details, can you talk a little bit about your journey when it comes to CI/CD and platform engineering? You have written a lot of books on platform
Yeah.
engineering, AI architectures, and things like that. Yes, that's a perfect segue. Maybe a little up so that everybody can see your book, and I will also put the links to the book in the show notes. But
Sure.
if you can provide a view as to what was the urge within you that you thought, okay, this is a gap that I see in the industry, and I want to write a book so that people get educated on this.
First of all, thank you for inviting me to the podcast, Tiku. You always been a supportive to me, and basically to the industry. So I'm really happy to be in this podcast. So as you are saying, the gap is stark right now. So most organizations still treat CI/CD as a pure engineering problem, something that DevOps or platform team owns. But what I kept seeing across the organization, especially the large enterprises and even the high growth companies, was the real bottleneck is not about writing the code or even deploying it. It was entire delivery system, the friction between the teams, the lack of self-service, ungoverned sprawl, inability to turn velocity into the reliable customer outcomes, especially the conversation between business and the technology team. CI/CD actually solved the last mile. Platform engineering is what happens when you realize the last mile isn't enough. I wrote this book because I saw too many organizations accelerating to technical depth instead of accelerating value. My book is to an attempt to give practitioners a practical blueprint, or more importantly, to give leaders a language for why this matters beyond the engineering organization and close the gap between between the platform engineering, technology team, infrastructure, and most importantly, business and the product teams.
So you said close the gap. That resonates a lot with me because that is kind
Mhm.
of the philosophy of what I'm trying to do in terms of Paalam Labs, the podcast, and all the other business lines that I'm trying to create. So let's close the gap, right? So, one of the key things, like you said, this is not just for the technical teams, this is also applicable for a C suite. So, if a C suite leader, whether it's a CIO, CTO, or beyond the CIO, CTO, if there's a CFO or a product executive who comes to you, what would you say that'll make them pay attention to platform engineering? The reason I'm asking that question is platform engineering, CI/CD is traditionally being considered like a, I don't want to say back office, but more, hey, this is a technology capability. What do we have to do with it? So, what's the first thing that you'll say that'll grab their attention?
Yeah, definitely. So you have put a very right point here, Tipo. So the conversation is this: platform engineering is not an engineering cost center. It is the invisible operating system for your business. When the code can be generated in seconds, the differentiator is no longer how fast your developers type. It's how fast and how safely that code can move from idea to the customer impact across the channels, or I would say omni channels, across regulatory boundaries, across multiple clouds, without creating risk or cost explosions. Most executives hear CI/CD and file it under engineering thing. What they're missing is that every day of friction in the platform shows up as delayed products, higher running cost, compliance exposure, and degraded customer experience. Also, nevertheless to say security issues as well. The business and the product cost of that blind spot is real and miserable. Platform engineering is how you convert engineering velocity into the boardroom outcomes, revenue, risk reduction, customer trust, and better, I would say, security exposures as well. That's what I would suggest our C-suite executives to pay attention on the platform engineering practices.
So, let's unpack it a little.
Mhm.
What I want to get is a better understanding of how platform engineering looks inside out. And there's no better place to start than talking about the the roles themselves. One of the things that I come from a tech organization, I've always worked with software engineers, and prevalently there is also this concept of platform engineers who have become more ubiquitous in the technology organization. And I've always wondered, hey, what's the difference, right? So for an audience, and this could also apply beyond the tech organization, right? For the audience and the leaders who are listening who don't have enough tech background, how would you differentiate a platform engineer from a software engineer? Where do their roles and responsibilities lie? And where's the distinction between what they do on a day to day basis?
I would say software engineer in the traditional terms build the features and product for the customers. And in contrast, a platform engineer build the product that the software engineers use. An example could be the internal developer platform or the IDPs. The software engineer optimizes the feature delivery. The platform engineer optimizes the system of delivery, self-service, consistency, security, observability, cost control, and reliability at scale. The distinction matters because if you treat platform engineering as just another flavor of software engineering, you underinvest in the foundational layer. You end up with hundreds of teams reinventing pipelines, security controls, and observability. And the CTO ends up with a slower delivery and higher risk. The chief hiring resource uh, people end up with a talent strategy that doesn't match the skills the organization actually needs. Platform engineering is a product discipline applied inward. I would say software engineering and platform engineering is the complementary to each other. Now, with the full stack engineering coming into the picture, both the roles are getting combined. But platform engineering is more upon the security, availability, uh, throughput, less latency, less maintainability costs can come into the circumference of platform engineering.
So to me, it's kind of like you're saying that the software engineers cannot exist without the platform engineers. But I like the way you put it that platform engineering has a product view for what the software engineers are going to use. Software engineers deliver the features, whereas platform engineers deliver the products that the software engineers use to deliver the features. That's fantastic. I think that's a good grounding in terms of where this conversation is going to revolve around. So the next step is let's unpack some of the capability. Again, kind of a grounding conversation for people to get an understanding, right? Let's talk about CI/CD versus the concept of platform engineering. I think people might be kind of aware of the concept of CI/CD, which comes from the DevOps world. How does CI/CD fit within platform engineering? What does CI/CD encompass, and how does platform engineering evolve or expand that particular scope? So if you can unpack the
Definitely.
capability around
Yeah,
those two areas.
definitely. First of all, I would like to demystify the CI/CD as an acronym. So CI means continuous integration and CD means continuous deployment. So what does it mean? It's like you have hundred of teams which are building on the product and everything is merging in one place. Sometimes it's in GitHub, sometimes in other source control. That is called the CI, continuous integration. You are integrating the things. And to demystify the CD, it's like continuous deployment. As soon as you are merging the code, you want to deploy it into the production fast, efficient way. So traditional CI/CD evolved to solve a clear problem. Take the code that developer wrote and get it into the production safely and repeatedly. It owned the pipeline, the last mile, actually. So the pipeline is the incubator which basically do the CI/CD for you. CI/CD is the concept, pipeline is the real thing. Uh, what what changed was the scale and complexity. Enterprises move to microservices, multi-cloud environment, regulated environment, and dozens and hundreds of teams. Suddenly, pipeline alone was not even sufficient. Teams needed golden paths, self-service environments, internal developer platform, policy enforcement, observability that span the whole stack and a coherent way to govern the sprawl. CI/CD, or I would say platform engineering, is a CI/CD evolved into a full internal product. It owns the entire delivery infrastructure, not just a pipeline. At enterprise scale, the distinction matters because without it, you get inconsistent quality, security gaps, runway cost, and developers who spend more time fighting in the system than building the value. So I would consider platform engineering and the CI/CD as the foundational thing on which your development team or the developers build the product on top of it and quickly and safely and efficiently pushing it into the production and giving the customer values ASAP as soon as they are done with their coding practices. It is not just helping the technology team, it is not helping the security team, it is helping the product, it is helping the business, it is helping the audit, it is helping the compliances, it is helping the whole organization.
So, if I can paraphrase it, and please correct me if I'm wrong, the way I understand CI/CD is it's the process and automation to get once the code is written all the way till deployment. The platform engineering is the entire capability or the ecosystem that makes sure that it's not just about automating a process, but it's about making sure it goes beyond into the understanding the people, understanding the culture, bringing together
Right.
all the hierarchies, all the way from the executives to the developers to make sure that what we deliver to the developer or beyond the developer is being delivered in a most efficient manner that impacts, to your point, around the larger enterprise goals when it comes to revenue or cost. So would that be a good distinction, that this is a purely a process?
Yep.
CI/CD is a
Yep.
process and
Yep. It
automation
is.
play, while
Yep.
platform engineering is an ecosystem and a capability play.
Yep. Yep. It is. It is a capability. Actually, you put it very right. Platform engineering is a capability. CI/CD is a product which runs on that particular capability. Yeah.
Got it. That's awesome. So one other question, just to set the stage before we jump into the details of platform engineering itself. So now we understood the roles and we understood what the capability entails. Let's try to understand where would be the right place for this capability to sit within the organization. So maybe it's very obvious for a CIO or a CTO, but if we want to talk about recruitment, we have to talk about other people like CHRO. We have to talk about the business executives who also have a skin in the game in terms of technical recruitment. So, in your view, what would be the right place for these roles and capabilities to sit? It's obvious it sits within the tech organization, but within the tech organization, where exactly would be the right place? Should it sit closer to the developers in the application development team or infrastructure team or somewhere else? What are your thoughts on that?
Think about uh, think about the platform engineering from the Google perspective, right? Google has come up with a term as SRE, or Site Reliability Engineers. Nowadays, there are new terms in the AI field is coming up. It's called forward deployment engineers, right? So earlier, yes, it was mostly running into the tech teams, but nowadays, what I'm seeing is there's a business and the product counterparts for the platform engineer because you are building a whole new platform altogether. In the most mature enterprises, it works best as a centralized platform team that operates like a product organization, which has the clear ownership, a product roadmap, and the internal customers. Mostly the engineering teams embedding pure platform work inside every product team usually leads to segmentation. A pure center of excellence without delivery accountability often becomes more theoretical. So the platform team should report into the technology leader who has both engineering capability and the mandate for enterprise outcomes like CIO or senior vice president of the platform or the cloud or the engineering effectiveness, or you can say developer productivity as well. So if you are more mature in your platform engineering practices, your security incident should be less. And it means your product's maintainability cost, the maintenance cost is less. And that would definitely affect the finance teams as well because you don't require that much people to run your product. So it has a cascading effect, but it should be running into the technology team, but have a very hand holding or very cohesive alignment with the product or the business teams as well.
So now we have a foundation. Platform engineering isn't a tool, a pipeline, or a DevOps initiative with a new name. It's a discipline. And like any discipline, it requires the right people to own it. Gaurav drew a distinction that's worth holding on to. A software engineer builds the features that customers use. A platform engineer builds the products that software engineers use to build those features. One optimizes feature delivery, the other optimizes the system of delivery. Both are essential, but confusing the two is where a lot of enterprises start to go wrong. And that's exactly what the next part of our conversation gets into. Because once you understand what platform engineering is, the harder question is how well are organizations actually doing it? In Gaurav's research and 2 decades of experience across large enterprises, the honest answer is that most are overestimating their own maturity. That gap has consequences, and they're not just technical. Platform engineering, when done right, is one of the most powerful levers of software rationalization, cost control, and ultimately customer experience. When it's assumed rather than built, that impact ripples across the entire enterprise. That's what we are unpacking next. I think you gave a very good picture for a person coming not with a tech background to understand what platform engineering is, what it means to the organization, and how does having a good platform engineering capability impact the organization at its enterprise level. So the follow-up question I have is, you wrote an entire book, and this, I'm sure there's a specific reason you wrote a book about. Yeah, that's an awesome cover for the book.
Thank you.
What is the, in based on what you've seen and based on your research, how well are organizations looking at platform engineering? What I mean is, what is the maturity based on your assessment in the current world, and what is one big gap or obstacle that they face to be able to achieve the maturity that it needs to have?
Very great question, Tipu. And that's where this platform engineering is it's a concept which has came around 5 6 years ago, but still companies are not able to adopt it fully. Most of the organizations rate themselves higher than the reality. They have modern pipelines and think that equals to the platform maturity, but that is not. In practice, many sit at the intermediate stage. They have automated CI/CD for some teams, for some cloud foundation, and pockets of good practice, but they lack a coherent internal developer platform or consistent governance on the self-service at scale. So if you go to any of the mature organizations, some parts, some teams which are really, really into the technology, they may have in the very small pockets, but when you go to the larger scale, you may not get it. And I'm saying that because some of the teams are running onto the newer tech stack, but some teams are running onto the older tech stack as well, and they are not adopting the platform engineering practices. Uh, the most common mistake is treating platform engineering as a tooling project instead of a product and the organizational capability. They buy tools, stand up some pipelines, and declare some victory, while developers still experience a friction. Shadow IT continues, and the business can't move as one. So they are in the one place they are spending money to purchase those tools, or in fact building those things, but the real outcome is not coming up. So I believe buying something and just uh, just basically putting couple of tools is not the CI/CD or the platform engineering practices. So CI/CD is just one thing, but that is not the platform engineering, and that's where I have seen. That's why market research says that most organizations are rating themselves higher than the reality.
So one of the things that you mentioned piqued my attention, right? You mentioned it's there is a challenge between that old legacy stack,
Yeah. Mhm,
combining it with the new tech stack.
mhm,
And you also
mhm.
mentioned there is a misconception of looking at it as tooling versus the product. So fundamentally, if I put all this stuff together, one of the classic problems that organizations have is tech proliferation, technology debt, which eventually adds up, that it creates challenges at the top and bottom line. Like, a lot of time people struggle to understand tech spend, and a lot of tech spend happens because of these things, because of so much debt, so much proliferation. You end up adding more people, to manage things that probably are not necessary, and eventually that's going to increase organizational costs, opex, capex, whatever be it. So, is there a way of taking the lens of platform engineering to help with concepts around rationalization, whether it's software or otherwise? And have you had experience doing anything similar to that, or what have you seen in the industry? We're just looking for like a real time use case around
Mhm.
that.
Yeah, definitely. You have said very right. Like a software rationalization is very important because within the large organization, some teams are using one tool, some team are using another tool. There is no one way of doing the things. Okay. So that's where the platform engineering creates the visibility and the control points that make rationalization possible. Many of the time I have seen in my professional career that many teams are using they just purchase something from out of the market. Maybe they have budget or whatsoever. And then when it comes to maybe it is working good for their team, but when they go to the other team, it is not working because other team is using something different. So there is no one way of doing the things, and that's where it it's a need of an hour art to have a platform engineering practices. So when you have a governed platform with a strong observability, with the API management and infrastructure as a code, you can see the redundant middleware, you can see duplicate services, you can definitely see a shadow infrastructure. And then you can offer the golden paths that make the preferred architect the easiest path. So you consolidate using the rationalization techniques by having a platform engineering practices or the platform engineering capability, and then you can document it using the golden paths so that everyone is using the one way of working. I can give you a practical example of consolidating dozen of custom deployment patterns and monitoring stacks onto a single platform with a standardized observability, security controls, and the deployment templates. Maybe organizations are using different deployment patterns. Okay, some are using maybe uh, blue green deployment, some may be using canary deployment, some may be using something else. But if you consolidate that thing and rationalize that thing using the platform engineering practices, that would give you the value and the security controls as well. I have seen that the teams migrate because the platform is better and faster, not because it is mandated it. Over a time, the long tail of custom system shrinks, total cost of ownership drops, and risk constraints decreases. It is a because it is a consistent process. We are evolving into the platform engineering practices every day, I would say. So having a robust platform engineering capability will definitely give a better rationalization so that architects in your organization or the business people who are owning those products can understand, is it the value coming out of it, or we should use some other tool which can promote the one way of working.
Yeah. So, one of the things I always both see and hear is, hey, my CMDB doesn't have all the inventory that's being used in the organization, or
Mhm.
my inventory is being stored in five different areas. I have no visibility in terms of what the single source of truth is. So what you are saying is basically an antidote to that. A
Mhm.
platform engineering capability is going to help both generate a consistent single source of truth in terms of all the infrastructure components I need, all the underlying tools and technologies that's needed for an organization, and at the same time be able to provide the right level of visibility to make sure you're
Yeah,
not,
observability. Yeah,
yes, observability
definitely.
in terms of not being able to use more than what's necessary.
Yeah. And one thing I would definitely like to tell that to promote the one way of working or one platform, it's very easy for your developers and the technical staff to go from one team to another and connect and create a synergy rather than sometimes, you know, some people are saying, hey, I have only worked on this particular tool. And so others say, I have only worked upon that particular tool. So the talent strategy will be simplified. It's not just a tool rationalization, it would be a talent rationalization as well. So that how it's going to be. So you know what kind of talent you want to grow on, what kind of talent you want to hire or like retain, so that you can have a one way of working. Otherwise, if it's too much tooling, if there is no technology practices or the platform engineering practices are there, the the tool sprawl will be very very high. And in that way, you get five developers who working on one tool and five developers working on some other tool, which is counterproductive in my opinion.
What Gaurav has laid out so far makes a compelling case for any CIO or CTO. Platform engineering done right creates visibility, reduces sprawl, and gives technology leaders the language to answer the questions they get asked in every budget cycle. What is all of this actually costing us, or is it worth it? But here's where the conversation gets broader because the impact of platform engineering doesn't stop at the boundaries of the technology organization. It crosses into the territory of the CFO, a chief product officer, and even a chief marketing officer have a direct stake in it. The consistency of what a customer experiences across mobile, web, physical branches, partner channels is not just product design objective. It's a platform imperative. The speed at which a company can respond to a market signal, fix an incident, or roll out a new capability, that's a platform imperative too. Reliability, in other words, isn't an engineering metric. It's a business metric dressed up in engineering language. So, next, we shift the lens from the back office to the customer, from cost optimization to experience, and from the CIO's agenda to the boardrooms. So, what you have laid out is a perfect kind of like addresses the CIO or the CTO agenda because they get asked all the time in terms of why are we spending so much on technology or what is the ROI. You provided a way to help them get that required level of visibility or be able to answer those questions. Now let's shift slightly, right? We made the case for platform engineering for a CIO or a CTO. Let's go beyond the tech organization, like a CHRO or a CFO or a product, like a CPO. For them, their concern is around customer experience. Can you make the case of why and how platform engineering also becomes critical to drive good customer experience?
Yeah, definitely. I would provide an anecdote here, okay? And the anecdote is that you want you want all the Teslas look same, behave same. You don't want one Tesla would be running in a different operating system and the other one is running on a different operating system. It means customer will get inconsistent things. It's a bit segue, but what I'm trying to come here is platform maturity is is very uh, is very pointed thing for the customer. So platform maturity shows up the consistency and the reliability across every channel. When the platform is strong, a change can be rolled out safely to web, to mobile, to if you have physical branches, if you have partners, uh, with the same quality and the observability. So your all the customers, doesn't matter if retail or like partners or any of those customers will get the same level of observability and the quality. When it weaks, you get fragmented experience. different versions of truth, slower feature delivery, and the outcome that customers feel. You will get lot and lot of complaints. People are writing it down onto the social media and those kind of things. And it's not good for the organization as well. A technology executive can make the case by linking platform matrices to the customer matrices. Example could be deployment frequency and the change failure rate correlate with the time to market and the incident volume. Observability maturity correlates with the mean time to recover and the customer impact duration. Uh, the platform is the enabling layer for the omni-channel consistency. So you get to know with the platform engineering practices that the moment you deploy the things, how fast it is basically rolling into the market for your end customers. If you getting the issues, let's suppose, how quickly you can roll back to the previous state, how you can get to see a minute details in your observability platform where, hey, is the customers are seeing or a specific set of customers are seeing some sort of issues. Say a customer is a grandfathered customer, maybe. Okay. And then you see that, okay, the customer who with the who with the organization for more than 30 years, these set of customers are seeing the problem with my particular change. That is that minute level things, or that the very uh, low level things you can get through your platform engineering practices and help the customer uh, to basically provide the right mean time to recover. And this will help your CEO, your chief marketing officer, your CFOs a holistic view about the customer journey.
I think that's fantastic, specifically how you explained that a customer experience is not just about the consistency of the features, the visual view of the mobile platform or the website. There is this subtle underlying consistency related to things like performance, speed, of how the technology gives that particular customer experience, which always becomes an afterthought. A lot of times people are so focused on, I want to build this feature, deliver this feature out, that the challenge becomes that those underlying metrics in terms of the environment, which doesn't immediately hit your brain but subtly impacts your experience. I really liked how you split those two, and platform engineering plays a huge role in that subtle experience that a customer goes through, which becomes extremely critical. So associated with that, I want to get into kind of like a education question, right? And this is more like you helping unpack certain terminologies. People hear these terminologies all the time, and I've noted down a few. I would like for you to explain to a non technical person what these terminologies actually mean and why it's critical. A few terminologies I have over here are chaos engineering. Sounds like a great terminology. I just don't know what it means. Performance monitoring, fallback systems, and all these fall under the concept of reliability. So, if you can set the stage in terms of why reliability is important and what these terminologies actually mean for it, that will be great.
Yeah, definitely. So think in this way, like we are now living in this era where apps are your life right now, right? And we expect the things to be available and reliable all the time. Example could be any of the ride share kind of applications, or your banking applications, or your food delivery applications. Every application, doesn't matter which industry you are in, you want reliability to be there. So when I was doing that research for my book, um, I have came up with a concept which I learned. It's called chaos engineering. Chaos engineering is a controlled failure testing. Think in such a way that right now everyone is running under too many microservices. Earlier it was just one monolith app. but you cannot scale it with the microservices. You can scale it like up to an infinite level. But the problem comes up if one service stop working, what is the system effect? No one knows. Say my database is down. What is the effect? My queue is down. What is the effect? One of my server is down. What is the effect? No one knows. So chaos engineering is a control failure testing. It is how you prove that your system will survive the failures that will inevitably happens. So customers don't experience them and regulators don't ask the hard questions. So you do these kind of controlled testing, sometimes of the database or sometimes of the messaging queue, sometimes of one of the server, and see what the system affect, and and see what will be the customer effect, and you document down those kind of things so that you'll know if there is an effect, what is the magnitude of that effect. So that is for the chaos engineering. One of the very good tool I would like to tell is called Chaos Monkey. For the audience to go there and look at it, and you will get to know how the chaos engineering practices are so prevalent in the current platform engineering practices. Now come to the second point, which was you asking about the performance monitoring and the observability. So performance right now, again, coming to the example of the ride share thing, you want the things to be fast, right? You want no latency. So you want to test those kind of things as well. You want to see that my performance of the app or any kind of website is paramount. Okay. You don't want to do, hey, I put my username, password, and your page is coming after like 10 seconds. It's like very bad customer experience. So performance monitoring, observability are the early warning systems. They tell, uh, we hope it's fine, into we know the health of every critical part in real time. So instead of assuming things would work, once you set up the performance monitoring and the observability practices, you know the health of your all the critical parts. That is very important when you interact with your customers, when you try to provide them a consistent results. Think about the Netflix, right? That you want to just click on it and you want the Netflix movie to come up. If it is keep scrolling coming up, it's a bad customer experience. Now coming to the point when you said fallback and the resilience patterns, in my opinion, fallback and resiliency is is some kind of insurance, actually. They limit the blast radius of any single failure so that the regional outage or the bad deploy does not become a brand or revenue event. So and that's where the platform engineering comes into the picture. As I said earlier, that you deploy something using a platform practices, say blue green deployment or the canary deployment. And if something start failing, you have built a fallback mechanism that okay, something start has start failing. Let's go back to the older version. Or you said, hey, if my if my error ratio is more than say 2% or 3%, let's roll back to the previous version so that you are providing uh, customer you are not giving customer a bad experience, and and the brand image always be intact. Uh, I would say for a CFO or a chief financial officer, there are risk and the cost levers. Uh, for a product executive, they are the difference between shipping confidentially and shipping fearfully. Reliability is a business metric dressed in the engineering language. So your 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 product teams or the business want a reliable product to be shipped into the market to our customers. So it's not just a engineering thing. It is a business term, but powered by the engineering team.
Gotcha. That makes sense. So, reliability, to your point, kind of like goes back to our previous conversation around customer experience. For a good customer experience, you need reliability. And the terms that you mentioned, chaos engineering, it looks to address unpredictability, performance monitoring is to make sure it's predictable. And the fallback system, the way I'm thinking about it is coming from a strategy background, is more like our BCDR that we talk about, business continuity,
Mhm.
disaster recovery, specifically
Agree.
for platform engineering capabilities. Would that be a fair summarization?
Very right term. Yeah. So the disaster recovery kind of thing as well. Although disaster recovery is for per site, but your fallback is per minute API level, or you
Gotcha.
can say application level. But the concept is same. So you are right there. Thank you.
Gotcha. Perfect. So now let's think about the governance aspect of it that becomes very critical. And here's the interesting thing about governance. We talk about tech governance all the time, but tech is not just tech. Tech goes beyond tech. And governance also gets interpreted differently. What people need out of governance is going to be very different. The CFO wants governance related to making sure the financials are good. The CRO is looking for risk mitigation, or the COO looks for operational governance, making sure the efficiency is good. So, how does platform engineering, although it sits within the tech organization, impact governance that helps address these different incentives from the different C suite leaders?
Yeah, definitely. In so the governance is important here because you really want your platform to be consistent. A, to be reliable. Uh, and three, it would be cost optimized and the risk mitigated as well. You also want the investment alignment here. So when you put the governance, you are putting the right compliances onto the platform engineering practices. You are making sure that whatsoever industry you belong, whatever compliances you belong, say you are from healthcare, there's a HIPAA compliances, right? So making sure that those HIPAA compliances are basically incubated within your platform engineering practices. Okay. So it will cover your security cost or the compliance or the audit thing. Let's suppose you want to introduce a a new feature or the new practices, and the unknowns are there, especially for the people who are the C suites, like you can say CFO, right? uh, in order to provide CFOs and the chief marketing officers, providing them that, hey, how you can mitigate the risk and how you can lower down the cost level. Platform engineering practices are basically helping them to ship the product confidently into the market. And that's where most of the mature organizations have all these C-suite people sitting onto the one table and understand how we can provide a consistent and reliable software, or because software is an entity right now, right? So how we can provide the consistent and the reliable software to to the customers, and so that they can generate the revenue, they can be consistent in the market, they can compliant into the market as well. So this is how the organizations which are opening up, or highly impacting organization, uh, is basically able to survive. If I give you one example, AWS is actually deploying around 2,000 deployments per minute, because they are able to get that scale over the across the globe with their robust platform engineering practices.
Gaurav closed the last chapter with a number that's worth sitting with for a moment. AWS, 2000 deployments per minute across the globe reliably at scale. That's not just an engineering achievement, that's a business capability. And it's the clearest illustration of what a mature platform engineering practice actually unlocks: the ability to move at speed that the market can feel. But here's the question that naturally follows: if that's what platform engineering makes possible today, what does AI do to that equation? Because AI isn't just accelerating the deployment side, it's compressing upstream the requirements, the design, the architecture, even the code itself. Gaurav has written extensively about this shift in his book, and his view is direct. The traditional boundary of where platform engineering begins is dissolving, and that changes everything about how enterprises need to think about this capability going forward. The conversation shifts now from what platform engineering delivers today to what it needs to become in the AI era. And the stakes, as you'll hear, couldn't be higher. Yeah, that's actually a key insight that you provided, specifically the speed of deployment, and that perfectly sets up the stage for us to talk about AI. So, the speed of deployment, AI has actually helped significantly. I've heard executives from Amazon, Microsoft, Anthropic basically saying AI could eventually significantly disrupt engineering and software developers. And it is kind of, in a way, doing it, right? At least from the point of the code being written all the way till deployment, we are using AI significantly. To your just the tidbit that you provided, AWS is going to has significantly increased the speed and the number of deployments, the frequency. The question becomes, AI can actually go beyond that. CI/CD, platform engineering, starts primarily once the code is written, getting it deployed, making sure it goes fast. But AI also helps upstream, all the way from ideation, requirements. Now you're thinking about more than just automating what you call, the DevOps, into basically automating the entire SDLC lifecycle. So what I wanted to understand is, how does that impact platform engineering as a capability? How is platform engineering evolving and adopting to this new AI frontier?
Yeah, I think that's a right way to promote the book again. So in my book, I have already put the AI-driven delivery automation, and I would definitely like to address this particular question. So the traditional way of doing the development without AI is developer is writing down the code, or the technologist, I would say, writing down the code, taking the requirement, design, initial architecture, do those kind of things, and it creates time, right? Before even you commit the code, it will take, or the CI or the continuous integration initiates a significant amount of time a technology need to spend for incubating the code or the software. But now with the AI, the traditional boundary is dissolving. AI is compressing the upstream phases, as I have mentioned, the requirements, the design, and the even the initial architecture. The platform engineering has to expand to govern the full path from intent capture through the AI assisted design and the code generation, through testing and the policy enforcement, all the way to production and the operations. So nowadays, in, uh, without taking any of the name of the models, but many of those models are, you can is actually provide the requirements to the model. It can write down the code. You need to review that code. It will write down the JUnits or the unit testing for you, or the automation testing for you. And then it can actually create a CI pipeline for you. It can actually merge your code into the repository. All you need to do is just making sure that, okay, it is written into a right manner through your code review or not. That's how the the initial phase of the development life cycle is basically compressing. Uh, what does it mean? It means the platform need not to provide just deployment pipelines, but also providing secured and governed environments for the AI agent. It should enable the policy of the code that applies to generated artifacts, the observability that spans human and AI contributions, The platform becomes a control plane and entire delivery system. Earlier, like before AI, I would say before January of 2026, people were actually doing the regular way of like development and then incubating into the continuous integration and the continuous deployment practices. But with the evolution of AI, that cycle has been reduced a lot actually. So I can definitely say this is really path breaking. But as I said, we need to be understandable and need to be enable the secure and the governed environment for the AI agents. That's what my take would be.
Yeah, that brings us back to comes a full circle. We did start the conversation between trying to understand the difference between a software engineer and a platform engineer because that was kind of the past and the present. But in the future, there is this term called forward deployment engineer that's coming into the mix, right? I've heard this word site reliability engineers. So if I'm using that word right, they sit a lot, specifically in the platform engineering team, in the infrastructure team. Can you unpack a little in terms of just like how you did for software engineering versus platform engineering? Can you unpack a little in terms of the difference between what's lacking in the site reliability engineer that you had to create this forward deployment engineer, and how does that particular role fit in the upcoming or probably the current AI world?
Yeah, definitely. Very good question and very right question in the into the current era. Uh, so traditionally, site reliability engineering or site reliability engineer came from it's a term originated by Google around 6 to 8 years back, where the CI/CD practices of the platform engineering was just a concept, and they are putting the people who are mostly writing down the scripts and the infrastructure as a code, though or like using the tools like Terraform and all, they are clubbing into one role or maybe an infrastructure engineer role with some product knowledge into the SRE world. Okay. So SRE traditionally focuses on reliability of the system, which is already into the production, which is the SLO management, okay, or incident response or the toil reduction. These kind of responsibilities lies under the SRE role traditionally, and that's why many of the organizations do had one SRE engineer within a pod. That's what the traditional model was. But now, in contrast, now with the evolution of AI, a power deployment engineer actually sits closer to the product and the customer edge. They take, they help to take new capabilities. Often it is the AI augmented into the real environments quickly, safely, with feedback loops that improve both product and the platform. So earlier, it was more of a handwritten scripts, or the SRE, I'm saying, handwritten scripts, managing the environment which are already into the production, sometimes production support as well, or making sure that your service level agreement or service level obligations are not going haywire. But with the forward deployment engineer, it is a person who is expert into the AI and mostly deploying and taking the requirements and developing the things using the AI augmented way, and help the product and the platform to move securely into the production environment. The rise of forward deployment engineer signals that the platform engineer is moving from pure internal enablement towards a tighter partnership with product and the AI layer. The platform has to support not only developers, but also the agents and the people who are deploying intelligence closer to the business problem. So earlier it was just the just the infrastructure or just developers. But now, forward deployment engineer who has the expertise into the uh, AI technology, they are also going to manage agents as well. That's what the fundamental difference between the site reliability engineer and the forward deployment engineer.
Yeah, that makes a lot of sense, and I understand the forward deployment engineer is a hot role right now. Google and all these big companies are heavily pushing it.
Amazon as well. Yeah.
Yeah, Amazon as well. I do have a provocative question. Very simple question. I understand it's evolved more from being this infrastructure platform role to becoming more the product level and the customer level. My question is very simple. Aren't we asking them to do a lot?
Well, I would say we are not asking them a lot actually. So earlier developers used to go to internet if they have problems or if they have issues into the scripting and all. But now with the AI and those big LLMs are there, it is definitely, I would say right now it is overwhelming for them actually. But in my opinion, with the maturity comes up with the AI platforms, the things will become uh, I would say manageable from right now, from overwhelmed to the manageable thing. Yes, you are right. In the forward deployment engineer, because it is a new term. It maybe people are thinking about, hey, he or she can do kind of development, testing, and AI agents and everything. But in reality, it is a very specialized skill, actually, there where you understand how the LLM works, how you can generate the good outcome without wasting too many tokens or the token cost. So that is where the expertise is. They are those people who who are experts into the prompt engineering, I would say, and understand what kind of things they require uh, from the LLM and which kind of LLM or SLM they need to use. It's like that. So
Yeah.
I would say it's a very specialized skill, but maturity will come in like some time.
AI is rewriting the rules of software delivery. The upstream phases that once took weeks, requirements, design, architecture, are compressing. New roles like the forward deployment engineer are emerging to sit at the intersection of product, platform, and intelligence. And as Gaurav describes it, the platform itself is evolving from a delivery pipeline into a control panel for an entirely new way of building. But here's the tension that sits underneath all of it. AI makes it easier, significantly easier, to generate code, spin up prototypes, and ship capabilities at a pace that was unimaginable even 2 years ago. And that's powerful. But velocity without governance isn't an advantage, it's a liability. The same force that accelerates delivery can just as easily accelerate technical debt if the platform isn't built to absorb it. Which brings us full circle. We started this conversation at the code level, understanding what CI CD is, what platform engineering does, and how these capabilities are structured inside an enterprise. Now, we arrive at the other end of the spectrum, the boardroom. Because ultimately, every line of code, every deployment, every platform decision either creates enterprise value or erodes it. And the leaders who understand that connection, both the engineers building the systems and the executives funding them, are the ones who will define what the next era of enterprise technology actually looks like. That's where we land this conversation. So from all this AI, it's making it so easy to create prototypes, create tools, applications, code, all that stuff. We did talk about the traditional challenge of huge technical debt, software proliferation. So now it does feel like AI is going to significantly increase it, right? So if I'm a CIO and I'm trying to invest or modernize my platform engineering capability, But at the same time, I need to think about not falling into the same pitfall of proliferation, redundancies. What would be your recommendation to both scale platform engineering, but at the same time address the traditional challenges that we just spoke about?
Yeah, definitely. So, great question. And that's how the transformation works, right? Uh, so, the answer is to treat the platform as the throttle and the guardrail at the same time. So, my advice would be invest first in the foundations that absorb velocity safely, strong augmented testing, quality gates, policy as a code, observability, and golden paths that make the safe way easy way. Then the AI aware controls need to be there, like scanning and validating the generated code, uh, tackling the issues which are coming, uh, which are non-contextual, and ensuring that the increased volume of changes still meets reliability and compliance bar. The CIO's strategic investment is not more pipelines. It is the platform that can scale throughput while constraining the risk and the technical debt. So making sure that AI agents and those AI code assistants are actually contributing towards the governed, secure, and predictable software delivery, having less technical debt and less risk as well.
So, on that note, let's wrap it up with one final question. Let's take a look at two opposite ends of the spectrum, right? Let's take a look at engineers and let's take a look at the board, because what you're recommending is think of platform engineering beyond the traditional. AI is going to disrupt it. So, the way these two people or these two groups of people need to think about platform engineering also needs to change. So, from an engineering point of view, what would be your recommendation if someone is getting into this field and wants to build skills in this particular field of platform engineering, but also make sure that what they do impacts the enterprise level? It's not about just them going and writing a code or developing an application. It's trying to make tangible impact from a market outcome perspective, from a business imperative perspective. What would be a recommendation for the engineer? On the other side, the board, we started this conversation saying CI/CD and platform engineering a lot of time becomes an afterthought. It's so considered like a, oh, it's a tech capability. What does that got to do with me? So for a broad perspective, what would be your pitch, or what would be your suggestion to take platform engineering seriously and go about it? So these are two completely opposite ends of the spectrum. Just
Yep.
curious, how would you position platform engineering for each of them appropriately?
Yeah, definitely. Yeah. I would like to address that one. So in my opinion, the workforce needs to be shifted from primarily writing the code to orchestrating systems of human and AI agents. Deep expertise in the platform principles, reliability, security, and the product thinking becomes more valuable than the pure coding volume. Enterprise that don't make the transition will find themselves generating more code than they can safely deliver, operate, or govern, which will create cost, which will increase the risk, and it will definitely increase the talent frustration. So my advice to the aspiring engineers is basically to master the fundamentals of platforms, observability, system thinking, security, and compliance as well. Learn to use AI tools as force multipliers, not as a replacement for judgment. The most valuable people will be those who can design the systems that let AI and human ship reliably at scale. That would be my advice, and that would be my thoughts. Now, coming to your second question regarding the board people, or like say a chief product executive, uh, kind of thing. And if we think about, hey, why should I fund the platform engineering at scale? I would say because platform engineering is how you turn the explosion of AI generated code into controlled, reliable, and low cost delivery instead of uncontrolled technical debt and customer risk. It is the difference between velocity that creates value and velocity that creates liability. Fund the platform or the cost of not having one will show up in your P&L, your risk report, and your customer matrices as well. And all in all, it will create a kind of a customer dissatisfaction, brand damaging things as well. So that those would be my answer for your two questions, Tim.
Yep, fantastic. I think this was a great conversation. To be honest, I feel like I learned so much about platform engineering, and you were exactly right. This is not just a technology capability. Yes, it sits within the technology organization, and it's primarily delivered by the engineering and the technology team, but inevitably and subconsciously pretty much everybody in the enterprise is consuming it, and it also makes a significant impact from a enterprise level. So you broke it down very well, all those concepts patiently and very clearly in terms of trying to help people beyond the tech organization get a good understanding of platform engineering. Appreciate you for your thoughts, and yeah, and good luck on the book as well.
Thank you. Thank you. And with your platform, I would like to promote the book. Kindly go and look at the Amazon with my author profile, and you can purchase the book there as well. And if you have any problems, just ping me, and I can see what I can do. Thank you, Tipu. Thanks for inviting me on this podcast. And I'm hopeful that others will learn from my journey as well, and can understand what the platform engineering is and how the AI is going to transform the platform engineering practices.
Yeah, definitely. Thanks a lot, Gaurav. Appreciate the conversation.
Thank you, Tipu.
And that's a wrap on our conversation with Dr. Gaurav Shekhar, author of Ultimate CI/CD for Platform Engineering, and one of the rare practitioners who looks at engineering not through the lens of technology, but through the lens of enterprise value. Fund the platform or the cost of not having one will show up in your P&L, your risk report, and your customer metrics. That line stayed with me because it reframes platform engineering from a technology conversation into a business imperative, which is exactly the bridge this episode was built to cross. What struck me most is how Gaurav made the case for two very different audiences in the same conversation. For the engineer, master the fundamentals, use AI as a force multiplier, and design systems that let humans and AI ship reliably at scale. For the board, platform engineering is how you turn the explosion of AI generated code into controlled, reliable, and low cost delivery. Velocity that creates value rather than liability. I want to thank Gaurav for bringing his experience, his research, and his honesty to this conversation. If you want to connect with Gaurav or find his book, his details are on your screen right now. And if this episode resonated with you, follow Paalam Labs on LinkedIn, YouTube, Spotify, and Apple Podcasts. There are more conversations like this one on the way, from platform strategy to enterprise transformation and what it takes to lead in the age of AI. Subscribe, share this with a technology or business leader in your network, and we'll see you in the next one. Cheers.